Hello and welcome. Is everything working? Uh, how do I do this? I can mute while I move the mic. I'm going to have to come up with hotkeys for all that stuff. Ugh. The mic is right where I'm going to bump it, and every time I try to move it, I can't get it to stay still in the right spot. But now the clamp just came loose and it fell off the windowsill. Because I moved it, I talked about how it was on my desktop and picking up the clicking, so I moved it to the windowsill, but the part for it to grab onto there is a little narrow, so I guess I'm going to put it back on the desktop. So I'll be muting again, so you don't hear all the noise. Okay, I'm back. Hopefully everything is working correctly. I apologize for the technical delay. So welcome back to the Voxel Fridays. Today's second edition. I want to get a little feedback from chat. Just somebody say everything is working at your end. I mean, it looks like it's working at my end. I can see the stream, and I can see the outgoing mic. Okay, thanks. So in today's first stream, I spent a little time going over some ideas for how an idea that I had this up on the whiteboard. Oh, I see that glare. How did that not? Oh, I know why. So I went over this idea for how to be able to hide quads at the boundary of the 8x8 regions by knowing what's in the adjacent regions, except at the very edge of the whole big chunk. Which, we'll go forward with some later date when we tackle that problem. And then I talked about a couple other things, expanded on the command lists. But I thought of after the stream was, and then I didn't feel up to doing any programming. I was kind of sleepy, and so I thought I would stream again now because I kind of feel like doing some programming, and this will give a different set of people a chance. Although it's the weekend, but maybe I'll try to do this during the week too. I'll do the occasional stream in the evening, so a different set of people have a chance to check it out. And so the thing I was thinking I might want to code is another strategy I thought of for how to do the voxelization, the meshification of the command lists. But actually, what I thought was maybe I could do this one offline, because I'd like to show everything. But I have mentioned that I might try like 3 or 4 different methods of doing this. And maybe I don't have to stream them all. Like maybe I could do one offline, and if it turns out to be a good one, then I can go over it. Obviously, I'd be happy to show everything to everyone, but like maybe sometimes I kind of feel like programming without streaming. So that might be nice. So I was thinking that. But then I was thinking, if I want to actually start trying different methods in the hopes that they're faster, there's a known task that I need to do that will actually be common to all of them. Which is, I said, if we're doing spatially localized regions, then I want to build a new set of command lists that are spatially localized, that only include the stuff that affects a given region. And even the method that we're doing right now, we run work groups of hyperthreads that that are these little localized 4x4x2 sized in the compute, but those actually directly translate then into here, that we process POS, which is global invocation ID. And that means that eventually there's a SIMD lane with a job for every single voxel in the region, but locally, while it's processing them, it's doing a little 4x4x2 region. And so that little 4x4x2 region is spatially localized. And so you could have a smaller command list that overlaps it. You probably don't build a command list for every 4x4x2 region, because you're going to spend way too much time building the command lists, because you're just going to only process that command list on one hyperthread. So having it might work, but you probably generate too much data. So, but what we can do, first of all, we can write generically, but as a first approximation, because I know I'm going to go to 8x8s, probably the thing to do is write a thing that generates 8x8 by full column coverage, creates a new command list for every one of those that's called to that. And then we can run the existing thing that I have here that's really dumb, that's really slow, and run that with the spatially optimized command lists. I didn't really explain what I mean by spatially optimized command list, but is it obvious, or have I explained it in the past well enough? Because if you're coming in with no context, of course, you'll have no idea what any of this means. So I can stop and explain it. It's not a big deal to stop and explain it if that's worth doing. It has been Voxel Friday 3 days in a row. Yes, that is a joke. Nobody has any opinion on that. All right. Well, then we'll just plow ahead, I think. How is my voice holding up with all the streaming? I haven't noticed any problems. It is true, though, that I'm talking way more than I normally talk, since I normally don't go out or do anything. So yeah, it is. Maybe it seems like it's getting a little lower. I feel like my pitch was higher in the first stream, which could be, drying out or fatiguing or whatever. What game studios have you worked for? No, thanks. Yeah, I guess I should make a FAQ of that kind of stuff too. I'm not sure what's on the official FAQ. Let me bring the official FAQ up, which is below the video. Where's my mouse pointer? Hello? I can't see my mouse pointer. I'm going to have to turn on those accessibility things for that. Okay, so what do we have in the programming FAQ? Dun, 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 dun. No, I don't talk about... Oh, here we go. Are you a famous programmer? Yeah. Check out the section that says, are you a famous programmer? The one detail that's not that in there is that I did some programming on the indie game Braid. And then I worked at Epic. This doesn't have my RAD or Epic credits, but I didn't work on Fortnite at Epic. I didn't work on a specific game. Yeah, so I worked with John. Braid was, back in 2000, whatever. And actually, that was remote. I worked from home. He sent me a... Ooh. I probably shouldn't say that. I mean, it's been 20 years, so... I worked... No, because he didn't send me a dev kit. I worked on the PC version. Yeah, I'm pretty sure, because he had it running on the PC and on the 360. So I think I worked... Yeah. I worked on just the PC version. I didn't have a 360 dev kit. That's definitely what happened. And I've mentioned yesterday that before that I worked in the Indie Game Barn, the office space that Chris Hecker was renting, that I sublet and John sublet as well for some amount of time. So we actually worked in the same space back in the days before Braid. Before he'd even thought of doing Braid. The issue isn't whether the NDA for the 360 is valid. It's if you have a reputation for having been secretly breaking the rules, then they won't work with you anymore. So I don't want to give anyone a reputation of not following the rules. Which is why I'm positive that my initial thought was just a mismemory, and I just worked on the PC version. Because, like I said, it absolutely was just working on the PC as well as on the 360. It's just the 360 was the only platform it was released for initially, but we had a PC build to make life easier, to allow people like me to contract on it and not need a dev kit. And who knows? Maybe it was totally legit. Maybe he could have sent me a dev kit, and it wouldn't have been weird. Like, Nintendo has these... I can't remember when it started, but at a certain point, Nintendo had these crazy rules that you had to have the Nintendo dev kit in a locked room with limited access and no windows, so that nobody could be spying through windows to see anything about it. Was that always the rule? Nothing's two. That was a rule that was active with Nintendo when I was at RAD, so sometime after 2008. It might have been true before that. It might still be true. I don't remember exactly which console it was that had that rule. So anyway, I want to start programming this command list filtering stuff. Now, one thing that means is that there are actually going to be two kinds of command lists. There's the command list that the CPU uploads to the GPU, which covers the whole chunk. And then there's a command list that is private to each smaller sub-chunk and, for example, could be recoded to be relative to it, which means you could pack the data more compactly, and packing the data more compactly might be good because it cuts down on your bandwidth, and maybe we're going to use a lot of bandwidth reading all these command lists because we're going to have a ton of them. However, I'm of two minds of that. One is that culling down the command list to be smaller. So, for example, right, the starting x and y coordinate, if you're calling your command list down to 8 by 8 or 16 by 16, then the starting x, y coordinates only need to be a couple bits. And it would only be interesting if you could get it down, the savings down to 32 bits. So one thing might be that you couldn't get enough savings. Like, let's take a look at a slab. So the slab, we can't change the z height. We can change the x0, x len. The x0 could be 3 bits, x len could be 3 bits, y0 3 bits, y len 3 bits. It's actually going to be 4 in the end. So we can push this down from 32 bits to 16 bits. But we can't save anything on any of the other ones. And if we're only culling in the xy, we can't save on the z. So I don't think on a lot of these we'd be able to actually save if we just always use 32 bits for how the things are packed. You could start packing down to 16 bits, but then you have to do more reads, and it's potentially not necessarily that much of a win. And keep in mind your chat is being archived on my video stream, so yeah, don't break NDAs in chat. So I think what we'll do is we'll just assume that they're the same. Now, the other thing is that, for example, if you took a slab and you culled the slab down to just a sub-region on it, remember the slabs have these, have separate textures for faces that are interior and faces that are exterior to the slab. And if you cull it somewhere, you're now creating a new false exterior face, because like it's actually part of the interior, but now it's at the edge of the cropped slab. So the logic that's cropping the slabs would then need to go and say, oh, I cropped the slab on the x-axis, let me update the x on the positive x side. So now let me change the positive x exterior texture to be the positive x interior texture so that the right texture would show up. So you'd have to do that work. You have to do that work on all 6 axes. All the jobs running in parallel would all have to do that work. So it would be a bunch of extra work, but probably not enough to matter, because you're just going to do this once up front. I'm betting that this is going to be like 0.01 milliseconds of the whole time. So probably it could actually do a bunch of work. So where I ended up coming down on it is it's probably worth having them crop it, if and only if we can get any savings. And since I just ran through the math and for the slab, which I expect to be the workhorse, I don't think we can actually shrink the command list. If we can't shrink the command list for the slab, it's probably not worth introducing the complexity that there are multiple command list formats. I don't know what the split the column into 2, so 2 linear lanes take care of 1 column is referring to. So I think that if you don't do it that way, then it has this nice property that this job that we're about to write, its only purpose is to cull the list. It doesn't change the list at all. It just culls it down and says which one of these actually apply to each block, which is nice because then it's not really relative to the size of anything. It can be used in multiple ways. We can use the same algorithm with or without building the culled lists. Yeah, but if I split the column into 2, that only saves 1 bit. It doesn't cut the bits in half. If this column is 1K tall, because currently it's at 12 bits, but I'm only processing 1K, and maybe I would only process 1K, so it could come down to 10 bits. And then if you cut the columns in half and do 2 processes, you could bring it down to 9 bits. And you could keep splitting, but then at a certain point you're generating a lot of command lists, as I mentioned before, and that might not be worth it. So yeah, I don't think there's enough savings here to be able to make it happen. The one reason to do it actually is because, yeah, I forgot about this, is because I really want these to be signed as well. I mentioned this before. I want the origin to be able to be outside of the 256 by 256 chunk so that you can describe a building. You make a building, out of tons of slabs doing all sorts of stuff, and then that crosses a boundary between two chunks, and I want you to be able to just use the exact same data you just had offset by 256 across the boundary, and it just works. And so to do that, on one side or the other side, the origin has to be negative. The origin of the slabs, like some of the slabs are starting negative. So I did do that sign for some places, but I didn't do it here. So if these are 9, now these need to be 7. But after culling, so the whole point there is so that the CPU doesn't have to do any culling. But during this culling step, the things could crop them down so they're only in the 256 by 256. And they don't extend out, and then they don't need to be signed. So you could save 1 bit on those from that by cropping it, or save even more bits by cropping it down to the 8x8s or whatever. But I think, and so I just stole from the length. I'm just like, oh, I guess you can't make a thing that's the full size of the map of the chunk, which is fine. The buildings are supposed to be a lot smaller than chunks, so if the caller has to do that, that's fine. But we could also steal from padding bits, right? We could say that like the padding bits are the sign bit, or the padding bits go at the bottom of or the top of Xland and Yland. We have a little bit of room to play if we want to. And of course, these texture IDs are actually only using 30 bits. So we could also try to be more clever with that stuff too. No, so I can't go to 8x8x8 because then I just have too many command lists. And you're spending all this time building all these command lists and then only using each command list once. And so you're doing the same, almost doing the same amount of work. Like you should have just gone ahead and done the filtering of the command list can just be done when you reach the point where you're not reusing the command list more than once. Well, it's more complicated than that. Because there will be a version of this that doesn't, yeah. Okay, so yeah, that actually brings me to another thing that I thought of, which is that if we do 8x8 by 1024 chunks, if that's one of the ways we make this work, where each lane gets, well, we're going to use 32 lanes, so each lane is processing 2 columns. That was that new proposal. But if you do that, there's 32 by 32 chunks. Oh, yeah, no, this wasn't. I was thinking of something else. If you do that, there's 32 by 32 of these sub-chunks. And that means there's 1,000 jobs, 1,000 work groups, 1,000 hyperthreads. And that's plenty of work in terms of, like, we want to get the GPU doing... Because we're not going to be able to do anything... Well, that's not true. We could actually do this asynchronously in the background because we're loading in a chunk that's out at the edges where we can't see it yet. So, but conceptually, a lot of the times for these things, you want to make sure, can I just throw the entire GPU at it, and it can, there's enough work for it to do, because if the next thing that you want to do blocks on it, in fact, that is true. If what's going to happen is that we do the compute shader in a couple steps, and we can't start the next compute stage until the first stage is finished, then we really want to make sure that there's work to fill the GPU, and I think 1,000 jobs is plenty. So yeah, so the current plan is we'll just use, I'm not actually going to fix this right now, the negation, the supporting negative coordinates, but yeah, so the plan is we will just use the same command list format for all of them. So I want this document to be accurate to what we're actually doing, though. So I'm going to update it like this. Okay, so let's start. All right, so this is going to be command list color regen, because it's not culling, it's generating multiple culled lists. Let's call it the command list color. Oops, I just missed. Oh, yeah. Thank you. Right. So the other thing I was talking about is I was saying these could be 9 and 7 bits because the signed X, signed Y, and we need the bits for those from somewhere, so we could steal them from X line or Y line, or we could steal them from padding. Bunch of options. But for now, we're just going to call it 8 and not worry about that part of it yet. We'll come back to that. After we've written more code, and more code will have to be fixed up. Now, one of the things... Yeah. Have I forgotten anything? No. I still haven't filled out this. I went to all the work to set that up. That's why we got rid of the chat box here and added the other chat box. Anyway, all right. So commandless color. I just started by cut and pasting the vertex layout. But we don't need to do any of that work. Are we going to need to do atomic offsets? No. An interesting thing I was thinking about is this is a pattern that I'm going to use in a couple places. This is the code that lets you atomically append to a buffer without using the atomic counter, but being efficient, manually being efficient, even if the GPU doesn't know how to do it. But the problem is you can't pass in. So this is the actual memory location that we're doing the atomic on, but we can't pass that in. So there's no way to make this a function that's like reusable. You can make it a function, like you could pass in an array index, and the array indexes into, I assume Atomic Ed would support that. And then you index the array into an array of data, and it could be usable on multiple different things. But you have to hard code in the name of the variable. I guess you could use pound define. Maybe that's the way to do it. But then you could still only have one of them per file. But maybe that's a tolerable compromise rather than having to cut and paste the whole thing everywhere. Why can't you pass it in? Because it's a GPU. You can't take the addresses of things. At least as far as I know. You can use in-out, but in-out just means it's a variable, a local variable, or the semantics. The point of this is that the semantics of in-out are that you read the variable and use the copy here, and then you store it back at the end, is sort of conceptually. I don't know. Maybe in-out does work for that. I assume it doesn't, but maybe it does. I have no actual idea. Can you use in-out in GLSL? Can you use in-out in a function to access a global atomic? Okay, AI says no, but let me search for a non-AI thing. Can I perform atomic operations on a function parameter? If the struct member is an array, you could pass an array index, but that's about it. Yeah, so no, you can't. Because the atomic operation wants to work with the memory address, and that requires the compiler to see the memory address. And in-out variables do not have addresses. In-out variables represent registers, effectively. But anyway, so yeah, I maybe we'll do this. I didn't really want to do infrastructure work on camera, but maybe let's do the infrastructure work. So which one was it that I was doing this? Is Big Ships that has this new approach. So Big Ships has this shader stuff. We actually went and buy it, and I just chose not to use it. Load shaders, maybe? Okay, yeah, so it has this thing, just a bit hacky. That's And we go back to CMC2. And I'll go over what it's doing when we put it in main.c. Where do we do shaders? We do shaders here. So let me reorganize this. This goes below. That should be 32. So the idea is just we load up a GLSL shader, and we'd like to have include processing on it, but I don't want to write include processing. I even have a library, STB include, to do this, but I just didn't want to deal with it. So instead, I just have this hard-coded thing where you can say #util, and it will automatically inject a utility file into the text. And then you can say #inject and inject some arbitrary string that you passed in specifically to this. So the reason to use inject is if you have #defines that let you configure what the shader does. So you've defined the shader so it can either do things with technique A or technique B, and you want to build two variants of it. So to make the two variants happen, you need to #define a symbol on or off, and you need to get that #define into the code somehow. And you can do that by concatenating strings, like GSL supports that. But because the version has to go at the top, it's just not worth the trouble. It's easier to just hard code this thing, and if you happen to, you can't put like a comment, like this is so dumb. If you put a comment in and say #util, it'll get substituted in. You put it in a string, it'll get, but it's a shader. You don't need to do any of those things. So we just use text substitution. So then we have to say, the first thing we do here is we say shader util equals load, or STB file name, not file name. It is shaders util.glsl, and it gets 0. So now, just by doing that, anything that calls load shader file instead of STB file will get that behavior. So we say load shader file. What does it use name for? Why did I have that? Oh, I think it might be so that you can pass it into crate program as the, yeah. So crate program takes the name of the program as a string so that in the debugging it can tell you which program died. So this is just the name thing is just a hack to let you do that more easily. I think it's might be the fourth parameter to that. No, this doesn't take the name. Only crate program takes the name. So I think that works. Now I need a util.glsl. And what goes in util.glsl? Doesn't get any version stuff, doesn't get any definitions. So we might have this idea. We could say if defined atomic increment variable, atomic add variable, get atomic append offset int increment, and for now this will be the only thing in util, and we'll see if we can make the existing measure work with this. So face count becomes increment. And previous faces becomes previous count. Oh, but this one is limited. This is a special one. 0, 1, 2, or 3. This one can only increment by 0, 1, 2, or 3. Most of the time, you actually only need increment by 0 or 1. So we'll do that. We'll do increment atomic add variable to increment, not to increment, total. Believe something like that. Let's flag this as untested. Chanzan, I made that FAQ like 8 years ago over the course of 50 streams, so a lot of questions came up multiple times, and all right, so now the one we're actually using, which can do 2 bits, let's say 2-bit count. Do we use the word count anywhere in here? Previous count. Yeah, let's use count instead of increment. Now, for now, I'm going to leave this thing where it's all scaled by 4, which is a hack. Because we also use this for our mesh, but I'll fix that in a second if this works. So total faces is now total. This is atomic add variable. Let's actually rename that to atomic add variable becomes atomic add global, to be a little more explicit about that. Previous count is previous low. I think that's right. So then we can go into the compute measure, get rid of this code, get atomic append offset 2-bit count. Wait, is that the right? Was that the one? How does it end up returning less than 0? There's no path that it returns. Oh, there is a path that it returns less than 0. Okay, that's right. And so then up here we want to say pound util, but right before the pound word util we say pound define atomic add global is index into mesh data. Yeah, like, you know, you don't have to be name calling, especially if you're going to put a hyphen in the middle of it to like prevent it from being word blocked. Is that why you put a hyphen in the middle of it? Is in case typing it in, does Twitch have some universal thing like that, or is it just because you thought I might have it blocked? Yeah, okay, that's fine. Now I need to ban myself for that. Unable to delete message. That's nice. Am I not logged in as myself on this thing? How can I not delete my own message? Weird. But anyway, so yeah, like, you know, like, you came in and asked these two questions that are questions that tons of people ask. They really are frequently asked. People are always asking them. And I went to the effort to make the FAQ that is under the video explicitly to answer all these questions. So it is appropriate for people to point you to the FAQ. But I'm still curious why you put a hyphen in the middle of jerk. Or did he already leave? Is he still here? How do I get a list of who's in the chat? Can you get a list of who's in the chat? There's an icon in community? No, that didn't do anything. Or is it because my chat has popped out? When I click community, nothing happens. But it might be because I'm popped out. He's not here anymore. Yeah. Because all I was going to do is, if he typed in a hyphen to get around a blocked word, I was going to ban him. Because if you're intentionally typing extra characters to get around a blocked word, you're not a appropriate actor. I don't know what to call it. You're not, you know, if you're trying to get around a block, if you're trying to get around a thing, yeah, it's not quite good faith, bad faith actor. It's like if you're trying to get around, put it this way, right? If you catch somebody trying to break into your backyard, you don't let them in your house, right? Like, you catch them trying to bypass a security thing, but that's not quite what the a word block is, but it's a community standards thing. If you're trying to bypass it. But yeah, I mean, sure, maybe he just meant jerk, which is why I didn't ban him for it. I asked him what he meant by it. And if he had said, yeah, he was doing it to get around a I don't know, do you even have the ability to block individual words on Twitch chat? I have no idea. But anyway, so yeah, just for future reference for people, you know, I'm happy to take out bad actors, although why I can't delete my own messages, I don't know. Anybody want to volunteer to get moderated by me? Like, to get timed out so I can make sure it's working, so I can time out someone, given that I couldn't delete my own message? Or here, no, somebody type something I can delete. Here we go. I'll delete Charlotte's yes, sure, if I can. Oh, except it scrolled right when I did it, and I deleted Uber Eats messages. Okay, so yeah, I can delete messages. Which is good, because I couldn't delete my own, and so then I was worried that, like, something was working. All right, so I will be able, I don't need to test the timeout. It's fine. I just wanted to make sure that if something does come up, I can do so. And of course, like I said, we can get moderators in here at some point if it's ever necessary. Because I am sometimes not watching chat for 5 minutes, and it might be that it's funny that they would have that rule, like the rule that if you can't take action against a streamer, which makes sense. Like you don't want your mod out acting your streamer, but like the priority interactions should be. There's also a special thing, which is the streamer can do anything, and so that should be the first rule. The streamer can do anything. Barring that, you can't do anything to the streamer. Barring that, a moderator can do anything. Barring that, you can't do anything to a moderator. You know, like sort of that kind of priority rule. It's very You're overthinking. Twitch is owned by Amazon. It's just regular enterprise software problems. That could be too. Okay, anyhow. So we wanted to check that I can make this measure work with this approach. What was the error message? Charge double star. Oh, I forgot to take address of name. Can't compile unexpected. Oh, this is going to break the line numbering. I forgot about that. Couldn't find compatible overlay function bit count. Well, why can't you find bit count? Oh, because it's... No. Like, why would that be... let's insert that into project. Yeah, I moved the bit counts down into here. Did I break the syntax when I was doing some of my changes? Okay, so this is line 2, I think. And then here we're at line 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, but then it doesn't count itself. So you go to 10, I think, actually. Which is why this was started with line 2. Something like that. Now let's see what the line number it gives us is. Future 10, 13. Oh, okay. There was an error before the bit count, so it's probably just that error, 10. It's just that it's easier to do the 10. Okay, so yeah, I missed the parentheses. Index into mesh data. Oh yeah, I've run this before I've defined the index into mesh data. That's just and at someday I'll come in and I'll inject those pound lines correctly. Anyway, so here it goes, and it looks like it generated correctly. So I guess it works. No, nothing to apologize for. I mean, I guess your tone was a little something, but not in a way that bothers me at all. Like, that's why I went out of my way in my commentary when I was describing, assuming he was still here, when I was describing that it was a frequently asked question. I basically reiterated what you had said, because I do think that was a valid point. Okay, so this is working. The util thing, so we can do other util stuff in the future. We can also share code. So one thing I want to share is packing and unpacking the command structures. That is something I posted maybe on Twitter, maybe on Blue Sky. Might be old enough that it was on Twitter, about a strategy for doing that makes it consistent. The way to pack structures that are accessed from both the CPU and the GPU by basically using the same code and cutting and pasting between them. And the idea is just basically you just always fully unpack the structure rather than accessing it a field at a time. You make a little function, and its only job is to unpack from the packed structure to an unpacked structure. The unpacked structure is a structure you didn't necessarily need ever before, but you're only introducing it just so that you can have code that isolates the unpacking to it, knowing that the GPU optimizer will go back through it and doesn't need to create the structure and doesn't need to create every variable at the same time depending on what it needs to do. But we go back to command list color. So what we're going to do is we're going to be outputting new command lists. So output command lists. And each output command list is going to be uints. It's going to be an array of uints. We're going to have 32 by 32 of them. And I shouldn't hard code that, but whatever, we'll hard code it for now. And then how long can the command list be? Well, each slab is 16 bytes, 4D. Each command is typically 4D words. It'll be filtered down, so it won't be all of them. So it'll only be a small fraction of them. How much can you fit in a thing? Maybe 2,000? How much storage is that? 2,000 by 1,000 is 2 million times 4 is 8. So let's say, like, if we made it 64K per command list just to be on the safe side, then that would be 64K times 1,000. That would be 64 megs. I think that's much bigger than we need. So yeah, we'll compromise and make it 32 megs. So that's our individual command lists. No, OpenGL doesn't have include. You have to implement yourself. And as I said, I do have a library called stp include whose only purpose is to do that. It doesn't implement pound define because that's built into GLSL. It just implements includes. But I just don't. I prefer to not have the. This way, it's the job of the C code to decide what gets loaded, so it's a little more secure. Not that security really matters for this, but just somehow I feel more comfortable with that. So these ones, we do not need to do atomic appends to these because each lane is going to output its own command list, and it can run totally private. Now, if we do 32 by 32 command lists, okay, yeah, this was the thing I was starting to get at. If we do 32 by 32 command lists and we use subgroups of size 32 SIMD lanes, each SIMD lane is doing its own command list at the same time, then we'll only have 32 jobs, and maybe that's not enough. An alternative strategy would be that each lane that you have a subgroup, you have a work group, subgroup, a hyperthread for, you have 1,024 of those. You have one for each 32 by 32. And then in parallel, the lanes read out the command lists and do the culling in parallel. But if you do that, the different lanes are having to parse different command list structures, so there's some wasted work there. And currently the command lists, each command is a different size, so how to step through it depends on the command, so you don't know how to jump forward in the list. So I think we'll stick with this, and if there's not enough work because there's only 32 jobs, then this step is a little more inefficient than it should be. But I think this step is going to be so fast it probably won't matter. So we don't build any voxel mesh, but we do have a command buffer. We don't need get mesh offset, which we just got rid of from the other file anyway. Okay, so and our layout is going to be 8 by 8. I mean, we could do 4 by 8 to get a size 32, but we'll do 8 by 8 because there's not going to be any synchronization internally anyway, so the exact size doesn't matter, I think. So we need to decide for each lane which command list are we going to generate out of the 32 by 32, and so that's done by saying I've got 2 paths. Take our GL global invocation ID and yeah, it's just that. It is just, okay, it is just GL global invocation ID of XY. Is that an int or a uint? It's a uint. So yeah, I'll convert it to int. And then we have num out commands. So this shared across all lanes per lane. Is there a thing that you can do in GLSL? Is there something to say that something isn't varying, basically? GLSL varying. No, but, yeah, not in that sense. In the sense that all the lanes must compute the same value. Doesn't flat mean... Doesn't flat mean the polygon shader that you don't interpolate? Which is also flat versus varying is probably the right change. It's uniform. There's a term for it in like RenderMan shading language, but uniform is normally used to mean sort of global, so I don't know that they use uniform that way in GLSL. Yeah, it looks like varying became in out. And so maybe there's no way to specify it in OpenGL. Basically, I just want OpenGL. It would be nice if it were self-documenting, if there was a keyword I could print in front of this that implies, oh, this is the same in all lanes. OpenGL Chronos Wiki GLSL. Is there a top-level discussion of GLSL? I'm pretty sure flat is just the thing that's used for do you interpolate vertex attributes or not. Constant expression, integral constant expression, dynamically uniform. It's dynamically uniform. Well, except I think GLSL distinguishes two kinds of uniform. Dynamically uniform means that the shader happens to have the same value in every lane, whereas there's a more uniform idea, which is that they're, by definition, always the same. Yeah, see here, whether an expression is dynamically uniform depends on the values provided. Like, if all of the lanes happen to compute the same thing, then it's dynamically uniform. So I'm looking for uniform. And it looks like they just don't have that notation. Let's look at removed qualifiers. And there was a reason for it, which is that the compiler can infer it. It's just, it would be nice if I could say, I expect this to be uniform over all lanes, and it's a compile error if it's not, to make sure I don't misuse it. Right, because the whole point is, all lanes, this right here we read from memory when we read the command list, and all lanes better be reading the exact same value. Now, of course, they are. We can see it from the code that they are. But it would just be kind of nice that you could explicitly say that. The varying qualifier, removed qualifiers. Varying qualifier is equivalent to an input of a fragment shader, output of a vertex shader. Yeah, it looks like they just don't have this concept in OpenGL. Or probably in most shading languages. Look, Ignacio Casano gets cited in an OpenGL thing. Like, they have invariants. Yeah, uniform means it's true across the entire thing and doesn't change, which is different. Yeah, here's your flat, which is, yeah, this is an interpolation qualifier, not a generic variable qualifier. Yeah, they just don't have a way to say that. it would be nice to be self-commenting, but so okay, and so then the region that we're responsible for we won't use vectors for this. X0 equals pos dot 8, no, pos dot x times 8 in x1 equals pos dot x. So 1 times 8 we'll do inclusive versus exclusive, we'll do exclusive. Int y0 equals pos dot y times 8, int y1 equals pos dot y plus 1 times 8. Let's use the fmad version. I prefer the, or not fmad, integer mad, which probably doesn't exist. Inclusive, exclusive ranges. So here I'm preserving the data we saw because we're going to write it out potentially if we are within the region. And we don't actually need to extract the z's. Okay, so what we want to know is, does the region we just read out of memory, so this is the command region, overlap our own region? And that is this crazy thing. The way you know that two regions overlap is the left is before the right and the right is before the left, something like that. So it's something like if x0 is less than cx1 and x1 is less than cx0, or I have that backwards, or is it greater? Well, I can reverse that one. It becomes cx0 is greater than x1, which can't be right. Can it be right? Well, they thought to put my name in it, so I think we'll assume it's a person that read what was on the screen. However, since I answered this question yesterday, I don't really feel like answering it again today. I think once a week. I think we have a once a week moratorium on repeating answers to the same off-topic questions. Nothing personal, just. So, what is the rule? If one range is like this, and the other range is like this, then this one has to be greater than this one. And this one has to be greater than that one. So yeah, the zeros have to be less than the ones, and the ones have to be less than the zeros. And I guess we'll stick with this way of notating it. Yeah, like nothing personal. It's a perfectly reasonable question. I just. Or was it even today that I answered the question in the earlier stream today? Not your fault, absolutely. Like, I'm not. Should these be less than equal to's or less thans? They're less thans because of the exclusive. So I think that's what this means, that they're in the range, I believe. So then what we do is we say num out we say command, yeah, these can't be the same name. Output commands. Oh, wait, but remember, we saw that if I do these big things, it breaks the link time. So I have to manually do this indexing. Or it needs to at least end with that. But you can't end on that side. You have to end on the inside. So I think that has to just be that. So then, and we have int j. Oh, it's num out. Yeah, let's just call it int j. Int j equals 0. Skip first entry, which is number of out commands, which we will fill later. Raid from the party of one. Great. So if we're in that region, which I think is that, we do output command list. I guess we'll cache this out base equals 32. That's 8192 times 32 times pos.y plus pos.x. And so then output command list of j plus plus equals data 0. Output command list j plus plus equals data 1. Output command list j plus 0 equals command list. And you're wondering why I switched from incrementing, and you will see in a moment why I switched from incrementing. The reason why I switched from incrementing is because that. So I think that's all it takes. I think that does it. Oh, and then I have to write the size at the end, which is a count, which I did have before, and then I deleted it because I forgot how this works. So we say count plus equals 1. And then at the very end, we say command list. This should be base plus j. I guess we can just say j equals out base. Yeah, okay. Output command list of base, of out base, equals count. I think that's right. Sure, I have a bug. Yeah, I got to put something on the screen. Well, I do have something on the screen that says that there's a fact below the video. Okay. Maybe I need to make that bigger. And then I don't need this illustration anymore. So this is what I wanted to write on the stream. That's not a lot. Yeah, everyone's always asking about the keyboard, and it's just because the clicks are coming through and sounding cooler. But it's a boring, cheapo, nothing keyboard. I should probably put that in the FAQ. It's a Dell keyboard that ships with PCs, or it used to ship with PCs, so it's super cheap. But this is particularly unique in that it has a tiny bezel, so it doesn't waste a lot of space around it. And when I used it, because of that property, that it takes up a little less desktop space, I decided I really liked it once I got used to it, even though it's the shitty, whatever you call them, squishy suction cup things, rather than real springs. To add an FAQ fact command, I would need a bot, wouldn't I? And so actually I started buying these off eBay, because I like that the no bezel, or whatever you call it, on a keyboard so much. So I own about like 30 of these, I think, from buying them off eBay. And That was one of my first forays into eBay, and the amazing discovery of eBay when you open up a package and suddenly you're like, oh, the person who sent this to me smokes. Yeah, I bought 30 because I was stocked up on them because they'll work for a long time. And I may not be able to buy them in the future, so I just stocked up. Because they are cheap. Like, a lot of them, the little legs, the two, there's two legs. Yeah, you can see one right now behind my hand, or in front of my hand. Um, Here, this hand. There we go. Those legs break off, and maybe I'll just need to figure out how to repair that. Get a 3D printer to print me a new thing to squeeze in there. If they do have a new model, I definitely will buy a bunch more. But it's I don't actually even care about the key feel. All that matters, because I'll learn. People swear by those mechanical keyboards with the clickiness or not with the clickiness, the green and red and whatever key switches. I don't know what they're called or whatever. And, this has that, whatever it is, soft rubber plastic squish thing that is molded in a shape so that when you apply enough pressure, it does collapse. So it is still, a click, but it's not based on a metal spring. And most people who are into keyboards are like, yeah, these mechanical keyboards are so much better. And I actually bought one and tried it for a while and was like, it just doesn't matter to me. It's not any better or any worse. And so since I knew I had the preference for the keyboard that doesn't waste a lot of space, and I didn't see that in the mechanical keyboard world, and I could get them cheap, I was like, I'll just, and the only reason I knew about it was because I had gotten a Dell computer at some point, and it had this keyboard with no border. And so since I knew it existed, I just started buying them. And it's fine for people who does matter to them, but to me, it just doesn't matter. In a similar way, I'm not a foodie. I don't have a lot of distinctive sense of foods being good or bad. I like sweet things sweet things are different in a certain way, and so I like sweet things in that way humans often do, but I don't, distinguish between a fine steak and a hamburger. Like, to me, they're just fine. Like, it's not that they taste gross, but it's not like one of them tastes awesome. And so in that same way, the keyboard is just like, yeah, I'm not a keyboardy. I accidentally deleted these. There it is. Okay. So I think this might be right. So we'll try it. So command list color GLSL. So we do another compute shader, and it's compute of 0 equals load shader file. I probably want to streamline this now at this point, because I'm going to have multiple compute shaders. Command list color .glsl. In the sense of like the KC tech code compression, where I'm doing the same thing multiple times, so let me start. Yeah, I mean, this code is identical. Oh, and this can be named. Oh, it can. Yeah, it can. %s colon %s. I think this is actually how the code was when I originally cut and pasted from somewhere. So yeah, now this code is all identical. Oh, and I misspelled color. You can potentially add info to your rules list. The rules will be displayed once someone tries to type for the first time. Yeah, that might be worth doing. And so then that gets stored in... Oh, right. I have to also call blank. Yeah, this definitely needs to get streamlined. I mean, you can see how load shader file was itself a streamline. The whole thing of storing the passing an address of name and storing it in here is just so that I don't have to create some other way to propagate this name down to the later code down here. Pinned a message in chat. Yeah, that worked. So now that gets built as color. Color. Am I pronouncing color correctly? It seems weird that it's a homonym for the RGB color. Maybe just in my accent. Good night. Color. And then what do we have to call it with? We need to create the output command buffers. So we command list is that, and then the called command lists equals create shader storage 32 times 32 times 8192 times 4, which that's 1000, so that's 8 megs, so that's 32 megs. And maybe it can be a lot smaller. Maybe this one can be a lot smaller. I have no idea how much it's going to take. We'll see when we get further down the road. So now we have the called command lists. I need to declare that. How long have we been streaming for? In about an hour. Yeah, because I stopped to talk for a long time. So what we want to do is get this running and then take the existing method I have and change it to take the called command lists and see if that speeds us up by a lot, which I think it will. Because we generate all these slabs. If we didn't have that many commands in the command list, it might not make a difference. But because we have all these, 6 into 24 is 4, so it's 40. So yeah, we have 44 commands, and we'll probably filter it down to 2 in most places, 1 or 2 in most places. So yeah, I expect that maybe we see a speed up of like 10 or 20x. It'll be hard to tell with OBS open, but we'll get some sense. Okay, so we have to bind and call it. So where do we do this? We do it before this one. So we say gl use program. What is build map doing? Oh, it's build map is this. Oh no, it is. Build map is building the command list. Okay, that's right. So we say color. We don't need that, but we do need this. This we should do after this. I think the reason for this, I mentioned this before when I did this. I think that the reason for this is that GL bind buffer, like the old school of OpenGL is that you bind buffer and then you do something to it. And that also happens to, then you do another command that just says do something to GL shader storage buffer, which implicitly is doing it to whichever one you last bound. And certain commands, and I don't know if GL bind buffer base is one of those, they introduced some commands that let you do it without having to first bind it. But what it looks like from this code is that I thought when I wrote this code that calling GL bind buffer base internally first binds vbuff to buffer base and then binds it into that slot. And so the unbind at the end is to keep it from being. Not that it matters, it's just a little cleaner if it's not. So then we GL dispatch compute 2v6 over whatever the local size is. God, I hate the way this works. As I've said before. It's 8 by 8, right? Yeah. The fact that part of it lives in the shader and part of it, yeah. So I believe that would work. We're not going to do anything with the data, so we won't really know if it works, but we'll get it compiling. We broke it. Okay, let's not run it and see what happens. Oh, wait. This has to be the output command list. Wait, what happened to the thing where we zero? Oh, no, that's not this. What happened to the code where we zero out mesh count? Oh, it's up here. Okay. Culled command list. No, what did I call it? Culled command lists. Oh, yeah, so it was that. I had the wrong thing bound and that broke stuff somehow. Okay. So now, let's go to compute measure. And let's copy in that other data structure. Oh, yeah, there's no data structure to it anymore. So let's ifdef it. Ifdef culled lists. Do this. Else that. Oh, well, this will cause us. Yeah. Okay. I know what we can do about that. This will break at first. It won't be perfect, but we'll fix it right after that. So now, when we parse the command list, we still assume. I only if-zeroed it out while I was testing it, but it did work. We're still only going to have a single unique command list. But we just say, which 8x8 region are we in? So where do we define? Oh, pause is which thing are we in? So here's an example of where it's not going to be obvious from the code. So if we take pos.x, which is in the 0 to 255, and we shift it right by 3 to divide by 8, because we're producing 8x8s, right? We're producing 32 8x8s. Each one is responsible for an 8x8 region. So if we take our x and shift it right by 3, so this is IVEC3 region, IVEC2 region equals pos.x.y. Shift right 3. And then the command list starts at this, which is I, starts at region.y or region.x. I think that's correct. And I don't think we have to do anything else. Except that's all only if it's... Okay. This is ifdef culled lists. And if that way. And then let's just call it command list in both cases so that we can use the same code. And then we define command lists, culled list, and this is dispatch. So, and then meshify if 0, we use that. And otherwise we use culled command lists. I don't expect this to work. I'm sure I forgot something. Yeah, it didn't work. They're all gone. I can't give any advice on starting programming because I have 46 years of experience, so I don't know what would work for new people. You need to find somebody who's been programming for like 5 years, maybe. This is another FAQ. God, I have so many FAQs. How could I possibly organize them so people would be able to read it without asking in chat? I mean, it's fine. I guess it's not the end of the world if people ask in chat. Okay, so the problem is what's going wrong. All right, well, first of all, let's put it back to the old way and make sure we didn't break that. Well, except we have to also put the shader back to that. Oh wait, did we enable the thing in the loop? No, we didn't. Okay. Command list color. No, the meshify. Commute measure. Don't define that and run it. Okay, that is still right. So we define that. So it could be the color that's broken. We have this thing to debug if the command list is empty. So let's try writing empty command lists in the color. So they should all be empty command lists. Except we don't actually want... we only did that when we were doing processing a very small region. If num commands equals 0 and pos dot x and 15 equals 0 and pos dot y and 15 equals 0 and pos dot z and 15 equals 0. That still might be too many, but we'll try it. So now if the culled lists are all empty, we should get this periodic pattern. And we're going back to culled lists is on. So we want this if to be the culled ones. Aha! So we are running the culled command list and setting the zeros correctly. Well, we don't know we're saying zeros correctly. It could be initialized to all zeros. Let us check instead if it is 1, 2, 3, 4, 5, 6, 7, 8. Hopefully this will not reset our thing if I screw up. And then we write out the same value. So is that code even being run? Okay, it is being run and it's set in the right place. We can also check that by intentionally not running it. So if we just don't run the color, then we have all empty, all zeros. Okay, so this is working in the sense that the color is running and the color is filling out the right data. And we were able to see the data. So the question is, why is the actually copying the command list not part of it not working? That's the measure. There's the command list color. So we do want to put this back to count. We're adding 1 to count for every command that gets output. We're outputting it. We haven't updated J. We skip the first entry so that we can write it. Then we say We load data 0, we check it. We load data 1, we check it. We output command lists, data 0, data 1, the 2 remain commands because there's 4 keywords per command. We do the last 2 increments. Add 1, add 2, add 3, add 4. We copy these 2 unchanged. Okay, well, let's just put all data into it. Make it just copy the same data through. Okay, that doesn't work. Oh, J. We're overriding J here. This was our thing to make sure we didn't reset the driver from it running for too long. So let's limit ourselves to 4,000 commands now. So maybe it's just because we're aliasing J. Yeah, okay. So it does work. Yeah, the problem with listing multiple facts under the stream is that people just aren't even going to see them. Or I guess I guess I could put them side by side. And by career fact, do you mean people who are asking questions, or do you mean about my historical career? People don't even look part stream. Yeah, that I assume is true. And I'm totally comfortable with people pointing them at the fact. People in chat pointing them to the fact. As long as and if the people getting pointed at it get mad. Oh, that worked because I didn't do any culling. So now let's do the culling. And it doesn't work. Okay, so the culling is wrong. Did I get this logic wrong for the order of the stuff? I don't think so. We're just asking to do the overlap. We're saying the range X to 8. We use the existing decode logic, so that should be right. Am I positive I didn't get this wrong? That's why I had that comment. You compare x0 less than cx1 cx0 is less than x1. That's what I meant to type, and then I got it backwards while I was typing it. I absolutely remember what I was thinking. I know that's what I meant to type. Okay. So am I actually writing the code? I think, oh, interesting. Got a bug up here. These didn't go through. Why would that be? Oh, and the back half didn't go through. Oh, because we don't do a barrier. We need to do a barrier. Storage. What is it called? Storage buffer? Social storage buffer? Storage. What are these called? Structured. No, not structured storage buffers. What are the SSBOs? I've forgotten what an SSBO stands for. Shader storage buffer. Yeah. Shader storage buffer wiki. Somewhere in here. Somewhere in here they talk about the things you need to do to keep them synchronized. Maybe it's not in this one specifically. OpenGL memory synchronization. No, synchronization means something else in OpenGL. Memory. OpenGL memory. Oh, I did say memory synchronization. Come on, get me to that page. I saw that page in the recent history. Okay, well, let's look for GL memory barrier. But I want it on the wiki, not on the docs. I guess it is GL memory barrier is what I want. So if I write to a shader storage buffer, and then I want to read from the shader storage buffer, access to shader storage box after the burial will reflect writes prior to the burial. That's exactly what I want. So, and you can see why you need it. Like, because what happens is it starts running the next command before the previous command finishes, or it doesn't synchronize the memory. And that happens. So we want GL memory barrier, and let's see if that is actually defined in my gl.h. It is. And I think that'll fix it. Nope. Did I put it in the wrong place? No, that's where it should be. Why does that not work? Is there some other thing that I also need to synchronize? I also probably need to synchronize after I generate it. And we haven't been doing that. The fact that I haven't been doing it just means it eventually catches up anyway, so maybe like one frame is wrong, but then the following frames are correct. One quick second. Oh, okay, I did do that. I just wanted to make sure I'm keeping my OPSEC up. Proof of the impossibility of the tying problem in your last stream. Ah, yes. Somebody proved that you can't do it with the 1x3 triominous. And it looked like, and I only skimmed it real quick, but it's the kind of proof that makes sense. Which is fun thing. But okay, so why is that? Okay, well, maybe it's not a memory barrier problem. However, like, because the data is so symmetric that I'm putting in, that's got to be. Although it looked pretty consistent, the bad behavior too. Like the way it failed seemed kind of consistent on both runs, which kind of makes it seem like it's actually a code bug, not a memory bug. But it seems like it's got to be a bug. Oh, and if you're going to do a GL draw indirect buffer, you also need that. So we actually also need that. GL command barrier bit, which is kind of going to suck. I wish you could express this stuff at a fine grain. I guess that's why people don't use OpenGL, because you can't fine grain express it. Because what you want to do is basically say, okay, here's this stuff. I'm going to create new meshes and that in the shared storage I need to be visible next time I render. But because I know there's a dependency between them, I'm going to do it one ahead. I'm not going to render it this frame. I'm going to generate this frame, render the frame, then next frame I'll try to use this data. And that gets it enough time to clear all the way through the pipeline. But there's no way to express, oh, I have this dependency from last frame that I want to make sure you've cleared. I don't want to wait for the new stuff to go through, because I don't want to wait. I don't want it to ever slow down. There's no way to directly express that. GL, on the other hand, historically would track and would say, oh, you wrote to this texture well, it would potentially do this. I don't know that it did. There were certain circumstances in which it did something resembling this. It would be like you did a drawing operation in which you you bound this texture as a render target. So I'm going to assume you've updated it, and then when you texture from it, I'm going to make sure that that render target operation has finished and I've run behind the scenes a thing to make sure it flushes to memory so that it gets picked up when it gets used as a texture. As I recall, it would just automatically do that for you in old OpenGL. And it would be nice if you could kind of get OpenGL to do that for you here and say, well, you wrote to the storage buffer this frame, so I'll automatically barrier it. And you didn't write to it this frame, you wrote to it last frame, and I know that that memory has already gone through, so I don't have to do any flushing. Whereas I'm just going to have to always flush, I think. What could be going wrong here? Because I'm doing the memory barrier, and I don't know what else I can do on the memory barrier side. That seems like that should do it. There's a memory barrier after every dispatch now, except the first one, I guess. Why is that not just the default behavior? Just due to caches. So you're flushing the caches when you call memory barrier. Data written by one shader invocation and consumed by other shader invocations launched as a result. Okay, but that's like a mesh shader kind of style thing. Yeah, okay. Data written to image variables in one rendering pass and read by the shader in a later pass do not need to use coherent, because it does do that automatically under the hood. Oh wait, but then what? I don't know what this line is trying to draw some distinction, but I don't know what distinction it's drawing. Because it's got an italicized barriers. And I don't know what that is referring to. Why is it italicized? What barriers is it referring to? Data written by the shader in one rendering pass and read by another mechanism in a later pass need not use coherent variables or memory barrier. The same thing. Calling memory barriers with the appropriate bit set and barriers is necessary. Or they're drawing a distinction between memory barrier and geomemory barrier. I think memory barrier is a shader function. Oh, and italicized barriers is this. Okay. Italicized barriers is this. So I think the distinction this is drawing is you don't need to call memory barrier in the shader, but you do need to call geomemory barrier like we're doing right now. So what could I do? What could I do to fix this, assuming it's a memory barrier problem? I guess I call GL all barrier bits. Nope, doesn't help. So maybe it's not a memory barrier thing? Maybe it somehow is a bug in my code? I don't see how it could be. How could this be a bug? If they were overlapping in memory, but I made them so big. They're 8192 long. There's no way. Unless the math is wrong. How could it... What could be wrong? How could I debug it? Okay, if it's a time thing, if it's a timing thing, then if we do fewer, then more of them, then the earlier ones should also be wrong. No, it looked about the same. In fact, if we look at this again, right, it looked like the back half just wasn't even being built, which kind of implies we're not. Oh no, it's yeah, it is. It kind of implies that like we have the wrong number of them or something, the culled command lists. Or I guess it could be not lining up. We could be loading the wrong ones. If we loaded the wrong command list. Okay, so how do we determine it? We take pos.x, global invocation ID, which we know goes from 0 to 32, 0 to 31, but 0 to 32 exclusive. Right, this is 32. So global numbers go from 0 to 32 exclusive. Then we multiply them by 8, which puts them up to 256. Pos.x, pos.x, pos.y, pos.y. And then we compute where they go at 32 times y plus x. That all seems like what I expect. So then when we read it, we take our pos, which is now 0 to 255, right, because that's here, and the shader is 4 by 4 by 2. Oh, wait. Wait. Am I doing the math wrong here? This is 32 over 8. 32 over 8. So it's only running 16 jobs. Yeah, I mentioned that before. Would that be enough to do it? Is it overwriting itself with bad data? Oh, it almost works. Except it's also still half the size or something. They're in the wrong spot. How are they in the wrong spot? Oh, or was it always narrow like that and I've forgotten? Was the old one narrow like that? And I've just forgotten already. Here's the correct one. Yeah, okay, it was narrow like that. On that axis. Let's make it a little less. Build map. Goes out to 148. Let's make it go out to 180. So more of the map is filled, so we can be careful about not being confused by that. So that goes all the way, and this goes most of the way. Okay. So now we go back to the culled version. Just this. Let's reverse the sense of that. Oh, still almost, but not quite. All the walls are fine, but the slabs are not quite right. Oh, no, that was probably true in the other one. Because I just expanded it and I didn't expand the slabs. Yeah, these need to go to 180. Okay, so I believe it's working. Almost working. This is 240, 240, 240. Why does this not go up to 240? Oh, it does here. Yeah. 400 to 401, 400, etc. 180, 180, 180. That looks like the very last things aren't being propagated through. Let's run it. Let us recompute the same thing multiple times. It will just write out the exact same data every time, but maybe the first one will have flushed through. Or from the first iteration will have flushed through and everything will be there. No, it's still not there. So maybe that's an actual bug, not a memory barrier thing. Okay, let's again go back to the non-culled version and make sure we know what it's supposed to look like. What am I shooting for? On my other streams, I'm working on this project, and on this stream, I'm working on this project. So read that and then ask a follow-up question. No, it's okay. It is definitely broken with the culling. So again, the question is it the culling that's broken, or is it the memory that's broken? So we re-enable culling. Now we're using culling. Then we go to the color, and we say, we'll do it like this. True or. So now we go back to the color doesn't do anything when it culls. Aha, and all the data is there. But if we cull, some of the data is missing. So that seems like there's a culling logic bug, but how could there be? When we just use the exact same formula for everything. How could there be a culling bug? An off by one bug? Like, let's slightly increase the chance of including a thing. Nope. There's a lot of context to the culling, the whole command list system. If somebody in chat wants to explain it, feel free. I can't task swap. I need to keep what's going on in my brain trying to debug this, so I have to stay focused. Why could this happen? It still looks to me like a memory. It still looks to me like a memory thing. I don't see how the code could do that. I verified that if I didn't cull, then it looked fine. That doesn't mean it's not a memory thing, because I changed its behavior and I changed the timing of its behavior. What if we went in a different order? So what if we change pause to be ivec2 to be 31 minus that? Does that work? Do I need to ivec2 it? So if we traverse them in a different order, same failure mode. Interesting. Well, if I'm traversing them in a different order and I get the same failure mode, it seems very unlikely that this is a memory thing. It seems like this has to be a bug. Yeah, I'm not blaming you for that, of course. That's just what? So we dispatch the compute. Am I not allocating enough memory? Like, that would be a way this could go wrong. We've had this issue with not binding the memory. I'm allocating 32 by 32 by 8192 by 4 bytes. That sure seems like enough. Yeah. How could I have a bug with this? I don't know what I could be doing wrong. Like, if I just didn't build the last list, well, okay, let's put that code back in. If the list is empty, if that list is empty, then we'll do this special pattern. So we'll get to see where there are empty lists. So there should be empty lists at the back here, and there aren't. Why are there no empty lists at the back? I see the bug. I see a bug. I don't know if it's the bug, but that sure is a bug. And this was wrong. This should be, okay, multiple bugs. I was wrong. It's this one that should be I plus 0, I plus 1. Nobody caught it, but that's okay because it was a weird thing to be doing. Okay, my guess is that that fixes it. Yeah, I was just trashing memory. Now, I still don't get the pattern here, which I don't quite know why. Why in these 8x8 regions? Oh, because, no, they should be empty. They should be empty. And so I should get the pattern. Maybe this is too sparse. No? Not sure why this part isn't triggering. And that's worrisome, so that's something to debug too. Yeah, I now that I fixed the bug, I guarantee you, if we handed that bug to the AI, it's not going to get it because it was so wrong and so not obvious what I was trying to do anyway. And so me doing it wrong, a thing that I was trying to do that's not obvious, that's why nobody in chat got it either. It's just like, if I'd spent more time explaining what I was doing there, I might have actually caught the bug, in fact, rubber ducky style. Okay, well, we're did I still leave whatever is that? It was command list color. Did I leave this in? No, I didn't. Okay. Yeah, the divide by 32 or whatever it is, 32 over 8, is just stupid. In OpenGL, you specify the size of the work group in the shader, and then you specify in the code the number of work groups, which sounds logical. And then the amount of work that gets done is one multiplied by the other, which sounds logical. But often what you end up with is you want to know the total number of items to process, is what you have X in your code. And in your code, you don't know what the shader says the workgroup size is. I guess maybe you can query it, but... And so if you could just in code say, here, process 256 by 256 over 10 by 1024, and it would do, the dispatch call would say, oh, well, I see that the workgroup size is 2 by 2 by 4, or 4 by 4 by 2. I'll divide by those and do it automatically for you. Like, that would make way more sense as an API for most of the cases that I work with. Maybe in the 1D case, it's cleaner, and certainly maybe it's cleaner this way, but yeah. So, yeah, it would be so much nicer if that. So instead, I tend to type the number of items I actually want, which is 32 by 32, and then I divide by the workgroup size. And maybe I could query it, divide by the workgroup size, and then maybe if I wrap that in a function, yeah, maybe that's worth doing. OpenGL query shader workgroup size. Oh, compute shader. This is inside the shader. The problem is I'm still debugging the color. Even though I fixed that bug, the fact that I'm not getting the zero behavior that I think I should, I want to fix that, and then I can answer. I never actually tested this, I think. Okay, so this is the behavior you should get when you have you have empty command lists. So if I do this, and that back half looks empty to me, it seems like that means the culling isn't working right in this back half because it's not doing empties. All right, what if we only generate one wall? Because it could also just mean I'm not culling. Am I not in a cull list mode? I am in cull lists here. And yeah, and it is running the color because we just saw that we were generating all zero lists. So that's definitely running. What was it I just started to do? Oh, I remember. I was going to change the map builder. If I just build one wall. Because I don't actually see what's getting culled, so I have no idea. I have no idea that the culling is actually working. I was going to performance check it to make sure the culling was actually working, but like it seems like the culling isn't actually working because these lists aren't empty. So it seems like everything is passing this. Or at least that first draw is passing this. I know why. Because I introduced a bug. Yep. Okay. So now we re-enable the map. And now the back will have the thing. And now we disable the thing. And now I'm going to do the performance test, and then I can answer your question. So the performance test is we turn off the color. So we turn off the color, and we find where we're generating the map data, which is here. And we take all this and we copy paste it. Into here. And we check our performance. Okay, so we're getting 1.5 milliseconds per frame. And now we tell it to run a mesh every time, to process the mesh every time. And we get 20 milliseconds, 21. Wow, it's just going up. It's just getting worse every time. Am I leaking something? Yes, I don't zero those command lists. I need to zero them. No, I do zero them. There's nothing not getting zeroed. Why is that going up? That's weird. Yeah, no, I always write out a 0 at the end of the cull, so... And I don't rely on what's already there. So it shouldn't. What is getting increasing over time? Is this really just going to grow with that bound? Like, I'm imagining that's what's happening is that the culled lists are getting longer and longer because it keeps adding new copies onto them because I'm running the color every frame. But I'm not running the color every frame. I'm only running the meshifier, right? Oh, and that isn't getting reset. Okay. Yeah. So we need to reset. We need to do... It's up here. No, it's not up here. We need to do that. We need to do that every time. We need to zero out the vertex count. So the vertex count was increasing every time. Okay, so I think now maybe this will be stable. So I believe it is now meshing every frame. And it's taking 9.5 milliseconds instead of 1.5 milliseconds. So it's spending maybe 8 seconds on it. So now if we switch it to taking the cull data, and we have always been running the color the whole time. We don't need to change that. Wait, that was using the color. Wait, what? Oh, yeah, because I changed it here and not there. Right. So we're not using the culled list. So we want to switch it to using the culled list, right? And we are generating the culled data, and we need to tell the shader that we're using a culled list. I should have put this all in a pound defined in the C file and made it automatic. But okay, so now in theory, it would be faster because we're using the culled lists. But it does have to do more memory traffic to the culled list. But what was it before? Was it 9.5? Or was it 7.5 before? I already forgot. I should have taken notes. All right, let's not tilt the camera so that we get consistent performance results. It's growing without bound again. we're zeroing it. Why is it growing without bound? What am I forgetting? What did I forget to switch? It was 9 or 9.5, yeah. Yeah, it was 9.5 and the other one was 1.5, so it was a difference of 8. Was what I said, something like that. Or difference of 7 maybe, but now what have I forgotten to change here? We're not using culled command lists. We've disabled culled lists here. We're still zeroing it. Why is it going without bounds? What did I okay, let's just use undo to get back to an earlier state. I don't understand. Why is it growing without bound now? I just fixed this. Well, except now it's growing faster too. What did I break? What did I change? I just did an undo and I didn't see anything. Yeah, this is where it didn't work. It was going without bound because I needed this code. Without this code, it was going without bound. And I added this code and then it stopped going without bound. Okay, now it's back to the old growth speed. Then I put this in. Now it's not growing without bound. But I lost the memory barrier. Did putting the memory barrier in cause it to start growing without bound? No. So now I can't recreate the case where it was growing without bound. Who knows? But yeah, look, it's 9.5. And then it's 1.5 without culling. And then if I turn on culling, it was 7.5. And now it's 6.5. So it goes from 9.5 to 6.5, which is less than I expected. I expected better results than that, unless my culling isn't correct. Did I leave the culling disabled or something? No, but then we wouldn't see any performance difference. Yeah, the culling is correct. We're not even culling every frame yet. Like, that was going to be the next test. But it's already not that much faster. I honestly expected like a 10x improvement. I mean, it is generating more memory traffic having to read multiple command lists, but I just wouldn't have expected it to. Maybe the problem is that like they all alias each other in cache. So let's change it to 8,000 and 8,000 so that they fall in different cache lines. They follow different addresses. No, it doesn't matter. I wonder why that's so much slower than I expected. I mean, to be fair, I have always said I need to optimize this, to use a different algorithm to optimize it. But I don't know why, if I'm culling the command lists. Well, I guess now is a good time to talk about culling the command lists. The 9.5 milliseconds is without culling, yeah. Okay, so what's going on is we're generating the voxels are what? What did I do? What did I just change that broke this? I did the 8,000 change, but I tested that and it worked. Or maybe I didn't look around and didn't notice it didn't work. 8192 on this one. 8192 in this one. Run it. No. What did I change? What did I break? How did I break this? What? most likely I just typed something in the code and didn't notice that I'd done it. But it is also possible that something weird is going on. One way that probably I'm calling the command lists, and then but using the wrong path for this. No, this one is using a non-called. If I bound the called command list and ran with the non-called, I think I would see this. But that's the opposite of what I'm currently set to. All right, let's get back to a stable state. No culling. Oh, it was the opposite. I'm culling. Yeah, okay. I'm culling, and then everyone is drawing from the same culled one. That's why that's broken. Yeah. Okay, all fine. But anyway, so yeah, I would have expected this to get more performance. But okay, so let me explain what's going on here. So this is this voxel map. Let's go up here where we have slabs so you can see there's something going on with the geometry. Although I need the textures to be... Okay, there we go. So I've got all these voxels. They're actually being drawn as triangles. And so somebody has to convert a voxel description to triangles. And the way that works in this scheme is that there is no big 3D grid of voxels at all. There is something called a command list, which says where to put voxels in big clumps. So like each of these slabs, each of these roof beams is what in the command list is a single slab. So the command list has 4 slabs to draw the sides of the walls, to draw the walls, and then 24 or something slabs that are the roofs. And so the thing contains like 28 commands. And the command is just a structure, a chunk of data that says, this is what I want. And then we are using a set of GPU shaders, of GPU compute shaders to generate the final mesh. So there is a shader which takes the command lists and for each voxel decides is this voxel visible or not, and if it is, it adds triangle data into the mesh that it's building. And it just does that in a very brute force way. We run one CPU thread invocation SIMD lane for every voxel in the chunk. But that command list that has however many 28 commands, most of those commands don't apply in most places. So it would be faster if we made a whole bunch of command lists and they only include the commands that are needed in each region with some spatial subdivision. So the culler is culling the command lists down into a new set of command lists where each command list only applies to a small region of space. It only includes the slabs or whatever commands that overlap that smaller region of space. Then when the voxels run, they load the command list only for the region of space that they're in. And as long as each hyperthread or work group of the command loads from the same culled command list, there's 1,000 culled command lists, but as long as every lane in the hyperthread is reading the same command list because they're spatially coherent, the lanes are processing voxels that are spatially coherent, so they all fall within the same region for the command list. Then it'll still be efficient because all the lanes are reading the same data. I do not have a wireframe view. I haven't worked on any of the rendering of this. It's just been focusing on the GPU shader, GPU compute stuff. Imperial Royal Guard, I cannot tell anyone any advice about getting into the game industry or learning to program. I'm too far. My knowledge is, I got into the game industry in the 1990s, and I learned to program in the 1980s. So none of my knowledge is applicable now. So to synthesize, no, none of those things. I do have the possibility of doing in the command list CSG style operations, but it is never meant to do. Okay, and then the intent is not that you'll be remeshing every frame to make changes. The intent is that you'll remesh when when you're moving around, you need to remesh as a new thing moves into view. To test the performance of meshing, I'm running it every frame. But that's just so I can see what the performance is without adding like a profile to it. Okay, so I got all the bugs fixed, but I don't quite understand why the performance isn't better. Although I don't have any sense of what the performance should be. And I am running OBS that is going to be mucking with it. But it was running at 1.5 milliseconds per frame. It seems unlikely that this doesn't represent a significant... Yeah. So why would this not be? Well, because we don't know how good the culling is. In fact, I disabled putting the pattern in the back. And I am well, no, that would be affecting both of them. The other thing is that the 9.5 versus 7.5 isn't, those times themselves may be inflated because it has to do the barrier to immediately prevent things. However, I don't know how I can avoid doing the barrier, so that is going to be true on any frame where we do generate new meshes. Yeah, the 1 millisecond was without remeshing. I'm saying the OBS overhead can't be that bad if I was hitting 1 millisecond per frame. Although the reason I brought that up at all is because I was seeing a much bigger OBS overhead on my Voxel, my compute shader raycast Voxel thing that I demoed way back when. There's an FAQ below the video. There is no bot here to answer your bot requests. How exactly does it decide that it needs to remesh a chunk? So the map is divided up into chunks, and as you move around, different chunks become visible, and you'll need to mesh them. If you make an edit, it will also need to remesh it. But I don't know that I'm going to have gameplay that allows you to edit. I don't know what the gameplay for this is. And when you add a block, it doesn't need to remesh. It only is when you remove a block that it would need to remesh. So do I just accept this performance because none of this code is final, so it doesn't really matter? I guess maybe. Okay, let's see how much it costs to generate the command lists. The cull command list. So that's this. But not use them. So we're just going to try to generate them. But we do pay the memory barrier cost. Okay, so looks like 1.75 to 1.8 is the most popular. And if we disable it, so I'm going to have to put some GPU profiling in to actually measure these. It's slower. So, now it's come down to 1.77. So it does look like it's the generating the culled lists is probably 0.1 millisecond or slower or faster. I will put in profiling, OpenGL based time querying, so that we can see the GPU costs inside the GPU. It's not frustum visibility. It's I explained this on previous streams, so I don't think it's worth explaining it again. Well, I don't think it's worth going to the whiteboard to explain it again. There's the command list describes, so the map is chunked into chunks of 256 by 256 by 1024 voxels. And there's a command list describing how to build everything in that chunk. So that command list is very long. It's going to have a bunch of buildings in it, and each building is going to take a ton of commands. So there's just a gazillion commands in it. And when you want, if you imagine that you have a GPU shader running, and its job is just to mesh an 8 by 8 by 8 region somewhere in that chunk, because that's how the GPU stuff tends to work. You'll have lots of little 8 by 8 chunks doing it. I just picked an arbitrary number. Then to do that 8 by 8 by 8 chunk, it has to iterate over this huge command list that's applies everywhere on the 256 by 256 by 1024. But it's not, most of those things aren't going to hit it because they're somewhere else in that chunk. You're only doing this little local region. This little local region is probably only inside one building, and there's maybe 40 buildings. I don't know what the number is going to actually be. So there's at least 40 times too much data that you're not using. You're just going to be ignoring it. And you're going to have a whole bunch of, so we divide the map up into 8 by 8 by 1024 chunks, and make a new command list for each 8 by 8 by 1024. Now, each 8 by 8 by 8 that you run, like the chunk that's at 000 can use the command list that's for 00, but so can the little tiny subchunk, the 8 by 8 above it, and the 8 by 8 by 8 above that. So there'll be a whole bunch of them that get to run using only the culled list, and only is looking at 100th or 50th of the data, because it's local. The command list has been simplified down to only include the data that's in that little region. So this is just about meshing, not about frustum visibility, because frustum visibility is at runtime. And it's just about saving work in the same way that frustum culling saves rendering time for not rendering chunks that you can't see, or subchunks or whatever. This is culling to eliminate render commands for voxel building commands that won't be used anyway, that will have no effect. Like you frustum cull meshes because they're off screen, so they won't actually change any pixels. And in this case, we're culling render commands that we know won't affect any voxels in a particular region. There's no direct metaphor, which is why I almost didn't want to call it a color, because I said it's a little misleading to call it a color, because we're not just culling for one thing, we're culling for 1,000 different spots. Well, it is at runtime. It's part of building the meshes, though, not part of rendering the meshes. That's the whole point, is there's all this info to it, and I could tell when you first asked the question that you just were thinking of something totally different, and that's why I didn't want to explain it. I'm on Windows 7 because I prefer it over the supposed improvements in later versions, and I don't know whether I could get VC6 to run on it. On later ones. I don't know. I haven't tried. Yeah, if the render time is what you meant by that, then I guess sure. But the point is that culling is a generic term. So frustum culling is one kind of culling. Occlusion culling is another kind of culling. And we're usually talking about culling triangles, but here we're talking about culling command list entries. But it's still culling in that sense. except that it is expanding by creating multiple command lists. So the analogy isn't direct, and culling is maybe not the best word for it, but you can imagine it's making 1,000 copies of the command list and then culling each one. That's sort of maybe the way to think of it as culling. So I don't know. I feel like I should have seen a bigger speed up, but I don't know that it's wrong that I didn't. I don't know what the color is actually doing because I'm not like querying back the size of the lists. It's just again a thing that we probably should support so that I can debug. But I think that's it. I think that's what I want to get done. And then, as I mentioned, I may offline try writing a different way of doing the meshing, because I probably will come up over the course of the project with 3 or 4 ways of doing the meshing. So maybe I'll try one offline, one that I don't think is going to be the best. And I'll only go through it if I end up using it. Yeah, the color was plenty fast. I just don't know why there wasn't a bigger improvement in the mesher using culled lists. Because the vast majority, the color is processing 4x4x2 regions of voxels. And so the vast majority of those regions, and to do a 4x4x2 region is looking at an 8x8x1024 command list. So that command list, most of the places, would have just hit 1 or 2 of the ceiling slabs. And so the command list should have been shortened down to 1 entry for most of the command lists, from whatever I was saying, 28. What is the actual number here? Was it 20? Was 28 right? 240 divided by 6 is, no, it's 40. 44 is the right number. So it should be shrinking it from 44 to 1 or 2 for most things. And so I would expect the meshifier to have barely any work to do, and I was expecting like a 10x speed up. I'm not going to talk about the OPSEC of my machine. The binary meshing that you're talking about is the part of the plan for the fast mesher, is to take the command list and convert it to bit arrays. The plan is to use 8x8x512 probably voxels, represent those as bit arrays in what's called shared memory on the GPU, which is a special kind of memory that allows sharing information between compute shader data stuff. So you do like an 8x8 region of bit arrays, and then all of the connected GPU threads or hyperthread can pull from that, so they can pull from their neighbors. So each lane will be responsible for 1 column of the 8x8x512. Each lane will be responsible for 1x1x512. They'll all do it. Then they'll synchronize, and now they can start pulling from that data to look at neighbors with bit operations. Yeah, that is the plan for the fast one. Except it's even more complicated than that, but close enough to start with. So I've not experimented with it in the past, but it is the plan. And I talked about that in the first Voxel Friday stream, I think, on Thursday. All right. So the idea is that it's 8x8x512, 1 lane, what some people call threads. Oh, let's do this. maybe somebody in chat can do this. I don't know how many viewers we have. Over 100. Good. Okay. So maybe somebody in chat can do this. Can you find a web page that has the terminology that people use for GPU threads, wavefronts, all that stuff? Because it's different between NVIDIA and AMD and maybe Intel. So because I keep having this terminology problem, this would be another good fact for me to have. Would be, what's the terminology I'm using, or what's the universal terminology, or I can switch between the different terms, but have on screen what the terms are. So can somebody find a web page that says wavefronts versus hyperthreads, or they probably don't use the Intel terminology, Intel CPU terminology, but wavefronts and whatever AMD calls them, and work groups in OpenGL, threads. If somebody can link to that, I will make a fact that explains how I'm using that terminology. That seems useful, since we're going to keep talking about it. Yeah, wavefront and warp. But I want all the terms. What do they call an individual SIMD lane? What do they call, etc.? So if somebody has that, can find a web page with that, I will draw on that power. There is not a universal terminology. That is the point. I want a web page that breaks it down. That here's what AMD calls it, here's what NVIDIA calls it, here's what OpenGL calls it, here's what D3D calls it, yeah. I guess it's not called D3D anymore, it's called DirectX, right? Yeah, okay. See, workgroup, warp, and wavefront, I'm not sure those are all the same thing. Isn't warp a different thing? Oh, no, right. Oh, sorry, workgroup. Yeah, no, you're agreeing with Psycode, yeah. So yeah, I think maybe those three cover that term. But let's actually look at ballot arb again. GL ballot arb. Bitwitch, thank you. Let me see if that actually has the answer I'm looking for, but I bet it does. Why can't I drag this? Why is this? Oh, it did let me do it. Okay. Warp, wavefront, a thread of SIMD instructions. Yeah, okay. So SIMD lane. So that's the term I've been using. But this is calling it a thread processor. I thought they called them threads. No, okay, this is not a SIMD lane. Wait, why do they say it's a SIMD lane? The hardware in which individual threads of instructions are executed. Collections of N cores. Where N is this? Share an no, so core in this sense is the same thing. So yeah. Okay. So thread processor is the SIMD lane. Yeah, okay, that makes sense. Well, I don't know why they put the word core there when we know that core means something totally different in hardware. Core, like the core is like the right. Doesn't NVIDIA use core to mean like you have SIMDs? You might have multiple SIMDs per core. Like the core is the thing that you have a texture unit attached to, or something like that. Yes, a lot of people use thread to mean SIMD lane, and that is the worst possible term for it. And we talked about that in previous discussions, why I don't like using that word. Thread block work group. So work group and wavefront are different things for AMD, but then OpenGL calls them work groups, calls the other thing work groups. And there is a reason why you could call it a thread, and I talked about that previously. But I think it's a misleading. It puts you in the wrong frame of mind to think about how to make your GPU, your compute shader efficient. The best way to think about how to make your compute shader efficient is to think of them as SIMD lanes, because that's what's happening under the hood. But anyway, so yes, now that I have this, I can make my own little FAQ for it. And I don't have room on my desktop for it. All right, we're going to put it in where the stream log is for now. Well, I guess, okay. Well, no, this was supposed to be individual bullet points in the plan. All right, so done is generate multiple culled commandlets. What did I do previous to that? What did I do this morning? I didn't code anything this morning. What did I do the day before that? It's in here. Generate mesh on GPU compute naive. Do any of these people have a term for? Oh yeah, see here's CUDA thread. That's the one I was looking for. Thread work item. Yeah, what a terrible term. Sequence of SIMD lane operations. I sometimes want to call that like a job, basically. What is CAAQA? Hennessy and Patterson. Did not know they'd updated with GPU stuff. Not surprised. I should probably buy a copy. So it used to be a really good book, at least. Yeah, no. I'm sure they do call it core in some, or somebody is calling it core in some sense, and it's a legitimate reason to. It's just confusing to use that word when you already have that used in the other way. So I'm not sure NVIDIA would ever call it a core, but maybe they do. Anyway, so where could I put? All right. Well, we're just gonna put it at the top of Streamlog just for a moment, just for now. GPU terminology. SIMD lane is CUDA thread AMD work item. Hyperthread warp. Well, okay. They don't have a term for it. No, they do. Hyperthread is the right term. Warp. Warp wavefront. Invocation. Work group. No, I'm not interested in looking at your voxel engine, sorry. If I say OGL, would people know that means OpenGL? So what I'm thinking is terminology. Stream terminology. What I could do is do this. Bring this onto the same line. Switch fonts. Pick a new font. Pick a not fixed width font. So I guess Arial will do. Make it regular. Make it a lot smaller. You'll have to tell me if it's too small. That's not too small yet. And now we can squeeze this in here without it taking up too much space. Except it's not actually a work group in OpenGL, it's a subgroup in OpenGL. So yeah, is there a term? What is the distinction? Okay, yes. So that's what this is. The thread block or work group is, well, no. Okay. Right, there's three things. Here are the four things. Okay. Let's use this. So at the top level, you dispatch a big compute job. So you have what we might call a compute job, which, for example, in OpenGL is, in OpenGL, I'm dispatching a compute job that has that many SIMD lanes of work to do. And that's split between the global and the local. So the num work groups times the local size. So that's the highest scale thing. And at the lowest scale thing, we have a SIMD lane, which is doing 1 by 1 by 1 of work in this sample, in the example thing that I have. Now we have the local group size. And for example, in another shader, it's 8 by 8 by 1. Right, in my local size for my I don't know that I don't have one in this, but in the past I've had an 8 by 8 by 1 thing. Oh yeah, the command list color is 8 by 8 by 1. But GL ballot arb. Am I misspelling that? Why can I find GL ballot arb? Why is it giving me this other stuff? Oh, because it's just called ballot arb. That's why. So you have this thing in OpenGL with ballot arb, a group of invocations from within a work group that execute in lockstep and can do limited communication. But these are not the whole work group. Maybe they are. This subgroup is the stuff that's physically running in lockstep. So this is stuff that's executing literally on a single piece of hardware with a single execution instruction counter. And in OpenGL, that thing only exists in this, and it's called a subgroup, for lack of a better name. So the subgroup size is on NVIDIA 32. But the local group size that you specify up here can be bigger. You can specify 256. You can make it be 16 by 16. Since the SIMD is only 32 wide, if you ask for 16 by 16 layouts, you'll get 8 subgroups have to run to do this. So what I call 8 hyperthreads. 8 hyperthreads are needed to do a single local size thing. So the local size is kind of this weird abstraction that just steps outside that. And so the question is, are wavefront and warp actually literally used to mean subgroup, or do they come from places that also have this distinct local group idea? I'm assuming they really do correspond to a subgroup, which is why up here I said this is a hyperthread, a warp, a wavefront, or a subgroup. So then OpenGL Compute Shader Wiki. And if I sound mad, I'm not mad at y'all. I'm mad at this terminology for being such a freaking mess. What, warp equals wave equals subgroup? You mean like this line that I just put up right here? A workgroup, the smallest amount of compute operations that the user can execute. But see, that's not what that is. So the work group is this, I think, in OpenGL. Work group size. So that's a work group. So what do I want to call it? And it looks like NV and AMD don't have any terms for it, because it's an abstraction that's part of the OpenGL API. They all have to run on one, because they can have shared local memory that they all see. They do often run on the same core, the same SIMD or something like that. So maybe there's no term for that in the other things. And then, do they have a term for like a dispatch? Do they ever call it like a job or something? Probably should look at the reference at the specification. Is probably where it would actually have that terminology. But we'll take the shortcut that we always do of looking at the extension for it and seeing what terminology the extension uses. So where's dispatch? So it's compute workload formed from groups of work items called work groups. So yeah, they don't give a generic term for a single dispatch here. It's implicitly a compute workload, but they don't call it that. Yeah, I don't see any terminology there. Warp and Wavefront are the actual hardware distribution of threads in a group, which is what the OpenGL ballot ARB calls a subgroup. So that's why I was saying, that's why. I don't know what anyone calls it in anything. I have no idea what terminology is for that. That terminology page was a good thing, but it was focused more on hardware and less on how the software sees it. Okay, we'll do that for now. So that's it. We're done. Thanks for hanging out. Any final questions, go ahead and ask them, and I'll answer them before or after stopping the stream. How many voxel projects do you think you've done? So probably between 4 to 8 in the 90s. I don't really remember. Then I had the Voxel City. And then yeah, no, that's fine that you asked all the questions. That was, yeah, it was after I had said that. So probably 4 to 8 in the 90s. I did this Voxel City thing, and then I did FCP Voxel render based on the city thing. And then I believe if I look in this directory that has all my games, I believe there are about 5 or 6 projects with Voxcall as the name of the project. Voxcall 2, Voxcall 3, Voxcall 4, and I think Vox 1 to 6. But some of those are just minor forks of the other ones. So probably there's 3 to 5 real ones in there. So we're probably hitting about 10 to 20 voxel engines that I've made over the years, I would guess. Hello and goodbye, because I just announced that I'm leaving after I answer questions. While working or studying, do you take notes on pencil and paper or mainly use whiteboard? The whiteboard is really just for talking to you guys. I mainly take notes in the C or HSL or H file that I'm working in. Like if I need to do a math derivation, it'll just be in comments in the code. And I don't study really in that sense. I'm not working at Epic. Check on the screen that you can see below my picture. There's 4 bulleted items under FAQ. Not the FAQ below the video, but the FAQ in that text file, and that has a great answer. And I could have said it much faster than that, but teach a man to fish. I do not believe I have ever read Structure and Interpretation of Computer Programs. I've certainly heard of it. Do you have any aesthetic preferences vis-a-vis programming language? I mean, probably. I don't know. I've just used C so long that what aesthetic preferences I have are kind of stomped by my familiarity with C. Like, for example, John Blow's language Jai has a particular syntax for assignment and declaration, which is x colon type equals 5. And that was something I suggested to him based on a sort of aesthetic preference. It was what I used in my language that I was writing called Stew. What do you think about functional programming paradigms? I think functional programming is a good idea, except that it causes garbage collection, so it's not great for system language type stuff. There's a book. Oh my gosh, I can't think of his name anymore. Chris O something. It's like a Japanese name. That is all about data structures in functional programming languages, and I think they're mostly, I don't remember if it's in the title or not, but they're mostly like, I don't remember what you call it, persistent data structures? What do you call a data structure where you can see all the history of it or something like that? I guess that's just always true when you use a functional language. Of course, anybody who keeps the pointer to the old ones can see them all. Chris, I own it, but unfortunately I don't have my books here. Is it a poem you just wrote here in chat? Okasaki, yeah. It was a Chris starting with an O and a Japanese name. Do you know what the name of the book is that I don't remember? Functional Data Structures? Maybe just something like that. Purely functional data structures. There you go. I believe it or not, I did say that before. Oh no, yeah. Because of the lag, I may have said functional data structures after that, but yeah. It's a gray area to post the link. Why is that a gray area to post the link? Just don't put in a associate. What do you call it? Associate link? What's the word for the... Do modern GPUs make... affiliate link, thank you. Do modern GPUs make voxel engines more feasible than in the past? I mean, everything is faster, so I don't know that makes them more feasible. Certainly, you could not do the kinds of worlds you can do with a voxel engine that I've done with voxel engines. You couldn't have done anything like that in the past. It was very hard to make a world that was voxel, a big continuous voxel world. However, there was a demo in the 90s of somebody doing that, and I don't know how they did it. And it wasn't super fast, but they never explained how they did it. So, link the actual PDF. Yeah, no, I would not do that. I just meant linking to Amazon or linking to a reference or something. Do you know anything about Bryce? I know it exists. I probably actually own it for various reasons, but I do not ever use it, probably. I don't know what sense you mean 3D CG. I'm not sure what distinction you're drawing with that. Okay, I have no idea what that is. Will visibility be able to handle transparent textures on boxes? I'm not quite sure what you mean by visibility in this context. But anything with transparency just has to go through a separate route to handle it, because it's going to have to be drawn last and all that stuff. If it were if this were my compute shader raycast one, it would be very different. Is that what that means? I have no idea. I did not know what that name meant. But he certainly is giving that impression. Oh, yeah, I see. But thank you, JetBlue, for that explanation. I didn't know what that was a reference to. Yeah, you can link a DOI. That was what I was trying to say. You could link anything that's a reference to it, not the actual, not a link to the PDF or a link to a link to a PDF or a link to a link to a PDF. Just info about it. Yeah, I've talked about the mod issue. That's like basically our first. I guess there was that one drive-by guy who said something and left, and then this guy. That's in 8, 9, 11, 14, 19, about 25 hours of streaming maybe. Anyway, this is the end of the stream for anyone new who's showing up. I'm about to. I guess I should just put that up in it. That'll be something to remember to do in the future. I need WordPad instead of. Okay, doesn't seem to be any questions. Oh, what's this OS that you're using? So, FAQ below the video. All your questions are answered there. No, it's fine. I know people don't see it. It's okay. That's why the FAQ exists. That's why I don't answer. I just point you to it. I do not have a stream schedule. I'm not streaming for the purpose of providing entertainment to people. Again, not criticism, just explaining. I'm not streaming to provide entertainment to people. I'm streaming for this reason, basically only. And so I'm not willing to impose a schedule on myself, because the whole point is I have not been very consistent about my programming. So I'm going to try to start programming more often, because I know doing a stream incentivizes it, and I don't want to do a schedule because that is a bigger commitment than I'm ready for yet. I may do a as I said in the very first thing, what I could imagine happening, not a promise, not even exactly a hope. I might have, yeah, I think that's what I said last time. But where I could see this going is a Monday, Wednesday, Friday streaming during the day. I'll switch to nighttime some of the times, or evening like this, just to let some people on different geographic areas do it. I probably will never stream after at 10 p.m. my time, because I don't want to get noise complaints, and that's our quiet hours at this apartment building. I think I did used to do that during OPBG. I might have done it because my schedule tends to drift. So I'm going to have to, if my schedule drifts, then I'm just going to not stream, or stream only in the early morning or late in the evening. But what we might end up with is Monday, Wednesday, Friday streaming, where Monday and Wednesday are working on a game, Friday streaming is STB or Voxel Fridays. Yeah, this is a question, the voxel question, that I actually want to uh, talk about a little bit more. But I mentioned this in STB. Yeah, the problem is I just don't know how loud I am to the neighbors. Like, I have no way of knowing. And the way that we get noise complaints here is really weird. I think I've got noise complaints, but I'm not sure because they come through management and it's ambiguously worded. So I think I've got noise complaints from playing Rocket League at night with socially, and maybe like I yell a little bit when I'm doing that, and without realizing it or something. So maybe it's fine that I'm just talking, but I don't know, and I just don't want to take chances. I wish they weren't ambiguous. Um, Certainly, it would be nice if I lived in a house by myself where I could just make noise and not worry about it. But whatever. Anyway, so the voxel engine question. So I talked about this a little bit in SB voxel render FAQ or Q&A, I think, which is just that the thing that voxels do, they serve a bunch of purposes. They're nice for procedural generation because it gives you this sort of simple, regular thing to build. It is certainly possible to do different. There's someone is developing a game called Vuntra City, Vuntra, which is a big procedural city, and I think she had mentioned that it's actually being built. A lot of the geometry is actually just built with instant stretched cubes, but they're stretched, as walls or something like that. They're not voxels, and there's a lot of other geometry as well in it. So it is possible to do other kinds of procedural stuff, but it's very convenient to do procedural voxel stuff, and there's sort of a bunch of things that voxels can do. Like, it makes user editing possible. You can have Ace of Spades where people dig and build barriers and dig out under each other and stuff, and Minecraft style building and some other stuff. And there are a few other aspects of voxels that sort of that I think I talked about in the Q&A and aren't coming to mind right now. And most people, when they say, I'm going to make a voxel game, they're like, I'm going to use all of that stuff. I'm going to make it user editable, user manipulable. It doesn't have to say editable. Maybe they'll make it that you can blow stuff up, and the blowing stuff up blows a hole in it. And that's just cool. And so they're like, I'm going to use all of those features that voxels offer so that I'm getting sort of the max value of being voxels. But in my opinion, voxel or block is also just a style. It's just a way things can look. I think the shadows of whatever that we talked about, shadow of whatever that we talked about the other time, the investigation game that's voxel. Shadow of Doubt, is that what it was? No, that's just a cliche. What is the shadow? Anyway, I can't even begin to answer that question. It's kind of a wrong question, and any answer that's useful to a question in that area would be too large. Shadows of Doubt, not Shadow of Doubt, but Shadows of Doubt. Okay, that makes it a little different. So I think you can just use voxels as the graphic style. It's very appealing for an indie because, like, you're low fidelity, you don't have to be super accurate, super nice, and so I think it's appealing to do that, and maybe proc gen. So that's what I'm doing, but you don't have to expose user editing, and you don't have to take advantage of all of the voxel features. So I'm not concerned about the gameplay implications of it. That's not why I'm doing it. The voxels are just there as a visual style to make procedural gen easier. The things where things like users can create and add and destroy blocks tends to have obvious immediate gameplay implications, and I'm not worried about those. Now, there could still be gameplay implications to using voxels in some more loose or abstract sense, or less tight sense. Yeah, it's loose, but I don't think it's particularly important to what I'm doing, especially since this is just an engine. I don't even know what game it would be. I'm really just doing this because I ran this old engine and was kind of, oh, this, I'd like to kind of see what this would be like if I did a modern version of it, of the city thing. So yeah, for people who didn't see that stream, why don't we at least right before we end, let's run it and show. This is an old engine from like 12 years ago or something that I basically want to recreate and do higher quality. It'll be with like this is very unfinished. The buildings are not supposed to be final. And then if I fly up, oh, this is the one where I still have this experiment running. So I was demoing this engine from 12, showing off this engine from 12 years ago, and kind of was like, I kind of want to make that again and make it better. And I had a specific idea for the gameplay for this version of it, but I don't know that I would do that gameplay if I did a game with it. What does Voxel have to do with Microsoft's faster malloc? Whatever. Okay, so I think that's it. We're done. Thanks, everybody, for being here. See you next time. And if you ask any questions as we're shutting down here, I can answer them in chat, but not recommended. All right. See ya.